Hello all, this is Scott Moore. I'm one of the senior technical enablement engineers supporting HPE within Ingram Micro. And today we're going to go over the Apollo and Cray XD server portfolio. To start off, if you're not familiar with Apollo or if you've never made this connection before, as opposed to HPE's ProLiant family of servers, the HPE Apollo family is meant to be a resource-dense server. Now, what I mean by resource dense kind of changes from server family to server family, as I'll explain as we go through. And a lot of what you find in the Apollo family kind of relates to the most recent releases from HPE in the Cray XD portfolio, which I'll also explain as we continue. So our agenda for today, I'm going to go through the three families of Apollo servers. We'll start off with the Apollo 2000, talk about the Gen 10, the Gen 10 Plus, and the current and future direction for that server platform. Talk about the Apollo 4000s, and we'll talk about both families within that, the Apollo 4200, Gen 10 and Gen 10 Plus, as well as the current and future plans for that family, and the Apollo 4510 Gen 10 and the current and future plans for that family. Finally, we'll talk about the Apollo 6500, which is available in a Gen 10 Plus, and we'll look at the current and future options for that family as well. So to start off, I want to mention the Apollo 2000 Gen 10. The Apollo 2000 Gen 10 has just recently been discontinued, but I'm going to talk about it a little bit here because you may still have customers who had standardized on it or may ask about it. The Apollo 2000 family was meant to be a compute-dense server. Remember, I said the Apollos were intended to be resource-dense. The Apollo 2000 was intended to be compute-dense. It came in a 2U chassis, which supported up to 4 server blades, each one capable of supporting up to 2 Intel processors. So in 2U of space, I could essentially do a 4-node cluster of dual processor computers, and that's where the dense compute comes from. On the right side of the slide, you'll see there were 2 different server blade families that go into the chassis for the Apollo 2000. There was the XL170R, which was available in a Gen 10. So this used the first or second generation Intel Scalable Xeon processors. This was half an Apollo 2000 wide and 1U tall. So I could fit 4 of these in there, 2 wide and 2 tall. On the right, we have the ProLiant XL190R. This was a 2U tall server, still dual Xeon capable, but I could only fit 2 of them in there, one on the left side of the chassis and one on the right. The advantage of the XL190R over the XL170, compute-wise, they were identical, but with the extra height granted me on the XL190R, I could put in additional expansion cards. So if I needed specific NICs or host bus adapters or something like that, something that I needed to add PCIe devices for, I might want to go with the XL190R and put 2 servers in there rather than 4 of the XL170s. I should mention too, you can mix and match the servers. So I could put in, say, 2 XL170Rs and 1 XL190R if I wanted to. I could also leave empty space inside the chassis, and there were blank modules to put in the empty server nodes just to keep the airflow directing the appropriate way for cooling. Now within the Apollo 2000 line, the Gen 10 line, there were 3 different chassis. And like the server names ended with R, you'll see the chassis all started with R. There was an Apollo R2200 chassis, which had 12 large form factor drive bays, 3 drives being assigned to each server node, or I should say each server slot within the chassis. The Apollo R2600 came in 2 flavors, a 24 small form factor or a 16 small form factor plus 8 NVMe drive version, again with the drives equally split up between the 4 slots for servers in the back of the chassis. The Apollo R2800 chassis was a 24 small form factor chassis, but it had a SAS expander built in, or you could get a version with 16 NVMe drives, but the difference on the R2800 chassis was that the drives could be dynamically allocated to individual servers. So I didn't have to split up the drive bays equally by 4 to go along with what I had in each of my server bays. If I wanted to assign more more drives to one server than another, I could do that. I could split up the storage bays unequally between my compute nodes. With the discontinuation recently of the Apollo 2000 Gen 10, we do have the Apollo 2000 Gen 10 Plus. Very similar layout, very similar functionality, but this is based on the third generation Intel scalable CPUs, as well as offering an AMD EPYC option. The servers and the chassis did change. So on the right, we'll see we have the Apollo XL 220N, and like the Gen 10 had Rs for everything, the Apollo 2000 Gen 10 Plus uses the letter N for everything. The XL 220N uses dual Intel processors, and the XL 225N uses dual AMDs. So similar to the ProLiant nomenclature, if a server ends with 0, it's Intel-based. If it ends with 5, it's AMD-based. These are 1U servers, so I could do up to 4 1U dual processor capable Intel or AMD servers in 2U of space for a 4-node cluster. There's also an XL290N, which is only available in an Intel version, and that was a 2U high server, again, in case you wanted to do PCI or needed the expandability for more PCI expansion. The Apollo 2000 Gen 10 Plus is available in an air and direct liquid cooling option. And if you're looking for the information on the components needed for direct liquid cooling, that is detailed in HPE's quick specs. For the chassis for the Gen 10 Apollo 2000, we had an N2600, which was supported with the XL220Ns and AMD XL225Ns. And it came in a couple different flavors. You could do 8 SAS, SATA, NVMe, so 2 drives per server slot, a 24-bay SAS and SATA, so 8 drives per server slot, or a 24-bay SAS, SATA, and NVMe. So again, 8 drives per server slot, but this was only for use with the Intel blades only. You also had the Apollo N2800, which was 24 small form factor bays. This was only for use with the Intel XL220N. And like the R2800 on the Gen 10, this allows for dynamic zoning. So I can split up those 24 small form factor bays unequally between my 4 server nodes if I want. If I want to do a true cluster and have the server storage divided equally between the server bays, I could do that. But if for some reason I was going to use the individual servers for different tasks and I had disproportionate storage needs, I could go with the N2800 and allocate those drive bays whatever was best for my need. In addition, not shown here, there was an Apollo N2400 chassis, which is still around. The N2400 chassis does not have any drive bays. So if you want this to be a driveless server box, you could do that and boot from M.2 devices or some sort of external shared storage if you want. Again, you can do up to 4 servers in 2U of space. So the density factor here on the Apollo 2000s, again, was dense compute, specifically dense CPU-based compute, because in all of these situations, I can max out at 4 dual processor capable servers in 2U of space. So 8 processors, 2U of space, 4 servers in 2U of space. Now, there isn't a Gen 11 version of the Apollo 2000. The Gen 10 Plus is still around, but the closest in a Gen 11 is actually the Cray XD 2000. You can kind of think of this as almost like an Apollo 2000 Gen 11. It is still a 2U chassis. It does have AMD and Intel offerings, and it can support up to 4 servers in 2U of space, 4 dual processor capable servers. If you look at the right side of the slide, you'll see we have the XD220V, which is Intel based and supports up to 2 processors, or the XD225V, which supports up to 2 AMD processors in a single server. 1U high, so half the height of the XD2000 and half the width. There is a 2U taller AMD server, which is the XD295V, for those customers who need the additional PCIe expansion, want to take advantage of the extra PCIe lanes that are available on Intel, or on AMD architecture. And at the very bottom, we have a picture, a rear view of the chassis with 4 XL 220X, meaning either 220 or 225V servers in the back. The left side of the slide shows the chassis itself. Supports up to 4 servers, as I mentioned before, 2 U of space. There are 8 small form factor NVMe drive bays, 2 allocated per 1U server slot. And the chassis does come in 2 versions. Unlike the Apollo 2000s, this is not based on how you allocate the drives, but the 2 different chassis versions of the Cray XD2000 are actually based on what you want to use for power. So the V2240 chassis is powered by 240 volts AC. The V2277 chassis is supported by 277 volts. So the last 3 digits of the chassis name is essentially the AC voltage intended to be used with it. And in the Cray XD2000 series, the AMD and the Intel servers cannot be mixed within a chassis. So you can definitely have the same, or you can mix the servers on a network, but within a single chassis, you're going to have either all Intel bladed servers or all AMD bladed servers. So the Apollo 2000 and the Cray XD2000 going forward are HPE's dense compute solution. Switching over to the Apollo 4000 family, the Apollo 4000 is meant to be a dense storage server. So for customers who don't necessarily need a ton of compute, but they do need a ton of storage. Think large databases, Hadoop, archiving solutions, backup targets perhaps. The Apollo 4000 Gen 10, which is bound to be discontinued on October of 2024, supports up to 1 or 2 Intel Xeon Scalable 1st or 2nd generation processors. It is 2U tall, and it has double the number of hard drives in the front that you would expect to find on a DL380. So I'm doing either 24 large form factor, split between 2 cages, or 48 small form factor drives, also split between 2 cages. So this is essentially a DL380 with double the number of hard drives. Dual processor capable, 2U, large amount of storage. So just think of it as a DL380 with twice the number of hard drives. If you need even more storage, there are options for rear bay cages. So I could add an additional 4 large form factor or 2 to 6 small form factor drives on top of what comes in the front 2 cages of the Apollo 4200 Gen 10. There are 10 redundant fans built into the system by default. So you don't have to worry about buying extra fan kits for redundant cooling or anything like that. There is also an Apollo 4200 Gen 10 Plus. Just like the Gen 10 Plus in the ProLiant line, this is based on the 3rd generation of Intel Scalable Xeon processors. Still supports up to 2 processors, still 2U of rack mount space, and still essentially double the amount of drives you could fit inside a DL380 in the front 2 drive cages. So I'm looking at either doing 24 large form factor or 48 small form factor drives in the front 2 cages. However, if that's still not enough storage for you, HPE has given us the option on the Gen 10 Plus of adding a 3rd, 4th, or even 5th drive cage to this. So we can add cages beyond the front 2 where most of the storage is. We can add 2 or 4 large form factor drives or 2 to 8 small form factor drives between cages 3, 4, and 5. Unlike the Gen 10, the Gen 10 Plus is listed as coming with 5 fan modules instead of 10, but the fan modules in the Apollo 4200 Gen 10 Plus actually contain 2 fans each. So you still have full redundant cooling with those 5 built-in fan modules, and you don't have to purchase any additional cooling elements for it. So going forward, the Apollo 4200, because it is a dense storage solution, has been moved from the Apollo server family to HPE's storage division. So you won't hear of a Gen 11 Apollo 4200, but if you're looking for the same kind of thing, really dense server storage, up to 2 processor support in 2 U of space, you want to look at the Alletra 4120. And the Alletra name has been used for a while for HPE's storage products. The same kind of technology, it's still essentially a server, dual Intel processors in there, generation 4 or 5 Intel Scalable Xeon processors, but it's now under HPE's storage division rather than their server division. So the Gen 11 version of the Apollo 4200 is essentially the Alletra 4120. Last thing I want to mention here is I also have the name ProLiant XL420 up in the title of the slide. I mention that here just because that's how the motherboard identifies itself. So if you happen to be managing it with integrated lights out, OneView, ILO Advanced, and a ProLiant XL420 shows up on your network and you're wondering what the heck that is, that's actually how the Apollo 4200 Gen 10 Plus motherboard identifies itself. The other server in the Apollo 4000 family is the Apollo 4510, currently on a Gen 10. This also supports up to dual Intel Xeons. This is using the 2nd generation Intel Scalable Xeons because it is a Gen 10 server. But it supports 2 pull-out drawers of 30 large form factor drives each. So I can do a total of 60 large form factor hard drives off of a single 2 processor server. These are large form factor drives, so typically SATA drives or midline SAS drives. So maybe this would be a good application for a large database, big data, Hadoop, that kind of thing. Object storage, maybe. I would see this more in use for an archive target, or perhaps a backup server where we're eventually going to offload backups to tape. But if you need a ton of relatively inexpensive storage, since we're using large form factor drives, the Apollo 4510 Gen 10 would be a perfect fit. Now, in both the Apollo 4200 and the Apollo 4510, we're looking at Gen 10 and Gen 10 Plus technologies, and that's because these servers are really aimed at being storage dense. As I mentioned before, compute may not necessarily be a big requirement for a server in this kind of arena. Again, think of an archiving solution. I need a server that I can push a bunch of storage out to keep a copy of that data for legal purposes or whatever. It's not going to require a lot of processing to do that. So a 2nd or 3rd generation Intel Scalable Xeon processor, or 2 of them, would be fine. There's not necessarily a huge need in a storage dense server for a ton of compute. But if you do have an application for it, there is the new essentially Gen 11 equivalent of this, and like with the 4200 Apollo, it's been moved under HPE's storage line. So we now have the Alletra 4140, which is essentially a similar Gen 11 conversion or Gen 11 version of this same Apollo 4510, but with Intel scalable 4th and 5th generation processors. The 4510 Gen 10, you can use the quick specs. I always recommend people to the quick specs for reference in building any products, but it does have a great example of which controllers to use, how to handle the layout of the drives in there, if you want the drives connected to a single controller or you want the drives split up by cage, 2 separate controllers. That is all detailed in the quick specs. But the main point here is if you're looking for highly storage dense servers, you want the Apollo 4000 line. If you want that with modern compute because you can take advantage of the 4th, or you need to take advantage of the 4th or 5th generation Intel Scalable Xeon processors for your compute, you want to look at the Alletra family, the Alletra 4100s. Now, the 3rd generation of Apollo servers I want to talk about are also compute dense servers, like the Apollo 2000. This is the Apollo 6500 Gen 10 Plus. I mentioned it's compute dense like the Apollo 2000, but the Apollo 2000 was CPU compute dense. The Apollo 6500 Gen 10 Plus is actually GPU compute dense. So the Apollo 6500 Gen 10 Plus, I should mention, is also going to be discontinued on October of 2024. Currently, the way it works is you can have up to 2 XL645D server cartridges in here, each with a single AMD 7000 CPU, 8 DIMM slots for memory, and attached to one 8-bay small form factor drive cage. Or I can put in a single XL675D server cartridge, which holds dual AMD 7000 CPUs, has 32 DIMM slots, and attaches to both of these drive cages in the front for a total of 16 small form factor drive bays. So I can operate this as a single server or as a pair of servers. This chassis is 6U tall, and I mentioned before that this was intended to be a GPU dense server. There's really nothing here that we explained so far that would separate this from a DL300 series server. 1 or 2 processors, decent amount of memory, some hard drives. The big deal about the Apollo 6500 Gen 10 Plus, support for up to 10 dual wide or 16 single wide GPUs. Now, for the GPUs that are going to be used in here, if you're going to go with dual wide, you might want to stick with 8, just because when you interconnect the GPUs, 8 is kind of optimal performance, but you can support up to 10 dual wide GPUs in here. The GPUs recommended for use with the Apollo 6500 Gen 10 Plus, the NVIDIA HGX A100, H200, or the AMD Instinct MI100, MI200, or MI210. And this supports NVLink and Infinity Fabric for interconnecting the GPUs. This is also available in air and direct liquid cooling options. So this is really kind of aimed at those applications like AI, deep learning. I suppose if you really want to do some sort of virtual desktops and rely on GPUs for the compute there, you could do that. So that is an option. Now, as far as a Gen 11 version of this, there hasn't been a Gen 11 version announced. But if you have an application that can take advantage of GPU compute, really don't necessarily need, in a lot of those applications, you won't necessarily need the latest, greatest processors. If your compute is primarily driven by GPUs, regardless of the fact that we're talking AMD EPYC 7000s in here, you have a ton of GPU compute available in this box. If you are looking for a box that will support both high-end GPU compute as well as some of the latest, or at least some of the more recent CPU compute as well, there are 3 options available on the Cray XT side of the house. The Cray XT 670 is kind of like an Apollo 6500 Gen 11, the Intel version of the what would be an Apollo 6500 Gen 11, if you will. Still 2 Intel Xeon CPU capable, 4th or 5th generation processors, 32 sticks of memory for a max of 4 terabytes, and up to 8 NVMe drives inside the 5U rack mount box. The Apollo XT 670 supports 8, no more, no less, NVIDIA H100 or H200 Tensor Core SXM5 GPUs per server. The SXM NVLink is for the GPU interconnectivity in this box. This box is also available in air-cooled and direct liquid cool models. Now, with the Apollo 6500, I could add however many GPUs I wanted, up to the limits I mentioned, 10 dual wide or 8 single wide, or I'm sorry, 10 single wide or 8 dual wide GPUs. With the Cray XT 670, you are pretty much committing to doing high-end GPU support from the get-go. And that's why your only option is essentially 8 GPUs in the box. And you're going to be going with either 8 of the NVIDIA H100s or the H200 cards, and that's it. You don't necessarily grow this box. You start with 8, you finish with 8 of those high-end GPUs in this box. Now, there are 2 similar AMD versions. First, we'll look at the Cray XD 665. Cray XD 665 is a 4U box, has 24 DIMM slots for a max of 3 terabytes of memory, and supports 2 EPYC 9004 series CPUs. So pretty decent on the compute side when it comes to current functionality in our processors. Supports up to 2 M.2 SSDs in a RAID and 8 small form factor NVMe drives as well. And this one supports up to 4, again, no more, no less, NVIDIA H100 Tensor Core SXM5 GPUs. So when you buy this server, you're buying a bundle of 4 GPUs for this server. The SXM5, again, is pretty much the high-speed interconnect between the GPUs. And if you're not familiar with SXM5, in a lot of mainstream servers, PCIe is kind of the standard for connectivity. If I'm connecting peripherals to a server or even to a PC or workstation nowadays. The SXM5 interface is built specifically for high performance among GPUs. So when you see the SXM5 interface listed for the NVIDIA cards, you're essentially going with the ultra fast interconnectivity interface that is used specifically for high GPU performance. Now the other AMD-based alternative to the Apollo 6500 is the Cray XD 675. The Cray XD 675 still dual AMD EPYC processors. This uses the 7004 series as opposed to the 9004 used on the XD 665. 24 DDR5 DIMM slots for a max of 3 terabytes of memory. And it supports up to 16 small form factor NVMe drives plus 8 small form factor SAS and SATA drives. If you look at the front of the chassis in the lower right here, you'll see there's 8 drives on the left and 8 drives on the right with the white dots on them. Those are your NVMe drives. Your 8 drives in the middle are your SAS and SATA drives. The chassis is 8U tall, and this supports 8, again, no more, no less, of the AMD MI300X OAM GPUs. So between our 3 families of Apollo 6500 alternatives, we have the 670, which supports Intel processors and NVIDIA GPUs. We have the 665, which supports AMD processors and NVIDIA GPUs. And we have the 675, which supports AMD processors with AMD GPUs. So plenty of options there for whatever your deep learning AI application requires. And that brings us to the end of the presentation. I hope you found this useful, and I hope this enables you to better position and talk about the Apollo and Cray XD server families with your customers. Thanks for your time today.